Okay, so if this is weird for you, then it's weird for me too. But this is the best way that I figured I could do this, and this is what I want to do, was show you how to work the kinetic and potential energy worksheet. As I said, these worksheets are the most important thing for you in doing your test. Knowing what kinetic and potential energy are first and foremost. So we have to know that kinetic energy is the energy of motion, which your PowerPoint tells you. And then potential energy is the energy of it's stored energy. It's energy of things waiting to happen. It means it hasn't happened yet, but we have the potential to do so. So there are two equations for these that you need to know. And so if I can, you see right here that there is EK, which is the kinetic energy, and then you have EP, which is potential energy. So for EK, the kinetic energy, the equation is 1/2 mv squared, where m is our mass and v is our velocity. And velocity is just how fast something is moving. So anytime you see something that says 30 m/s or meters per second, that's going to be the velocity. And mass, of course, is a weight. It's how much something weighs. And weight can be in kilograms, grams, pounds, ounces, whatever a weight is, that's what the weight could be. And then when we talk about potential energy, so potential energy, or EEP, is weight times height. And so height, of course, is how tall something is, and weight, again, is how much something weighs. So if we look at the first one, it says you serve a volleyball with a mass of 2.1 kilograms. The ball leaves your hand with a speed of 30 meters per second. The ball has what type of energy? Calculate. So if the ball is leaving, is moving, and it has a speed, we automatically know then that it has what? Yes, kinetic energy. So that means that the ball has kinetic energy, and therefore we must use the equation for kinetic energy. And so I'll try to transition and show you how that goes. So, as I say, this is going to be weird for all of us. We said that kinetic energy, I write it as KE, but it also can be E of K, right, is 1/2 mv squared, where m is our mass and v is our velocity. So for the first question, it says that we have a mass of 2.1 kilograms. So this is what I call our plug and chug. So I'm going to have 1/2 is 2.1 kilograms, and the velocity, how fast it was moving, was 30 meters per second squared. Now all we did was look at it and plug and chug. We got the weight, which is 2.1 kilograms, and then we have the velocity, which is 30 meters per second squared. Now here's the kicker. You have to remember your math. When you do math, you always do what? Order of operations. So the first thing we're going to do is do our square first. So it will then look like 1/2 2.1 kilograms times what? What is 30 squared? That's going to be 900 meters squared per second squared. Alright, so now we've taken 30 and we've squared it, and that makes us 900 meters squared per second squared. So now we go through, and we do the math. 900 times 2.1 kilograms is equal to 1890. So now it's 1/2 times 1890 kilograms meters squared over second squared. All of this go together. Keep up with your units. Okay? So now that we have that, we'll do half, or 0.5 times 1890, or 1890 divided by 2. But we want half of 1890. So we divide that by 2. That equals 945. So the kinetic energy is now equal to 945 kilograms meters squared over second squared. And this is always known as a joule. So your answer in the end is kinetic energy is equal to 945 joules. Okay? So when we're talking about doing a kinetic energy problem, this is how you work it out. Starting at the beginning, kinetic energy, 1/2 mv squared. M is your mass, v is your velocity. 1/2 2.1 kilograms. Remember, mass can be any weight. And then velocity is always the speed. This is meters per second. You always see it if you don't know math and think it's m divided by s, which is really meters per second. Squared, we do our auto operations first, so we do the square first. Please do this all the time or you will get it wrong on your exam. So 30 squared is going to be 900, but we also have to square the meters and the seconds. So now we come out with 1/2 2.1 kilograms, 900 meters squared. Multiply 900 times 2.1 gives us 1890 kilograms meters squared per second squared. We remain and keep all of our units. And then that goes 1/2 of 1890. That means 1890 divided by 2. Or times 0.5 is 945 kilograms meters squared per second squared. And that always equals a joule. And so your answer is 945 joules. Okay? I hope that has helped us with understanding how to create a joule.